A lot of utilities want to use what they currently have. They're looking at their existing lines, seeing how far they can push those
What's the
limits.
process and where do you come in terms of planning, implementing, follow up?
Southwire's kind of put itself in a unique position with its C7 conductor. They give you added flexibility, reliability, and also strength redundancy.
Everything out there is AI. How you see artificial intelligence and automation tools playing a role in this overhead space.
AI is a great tool, but it's not a
We
replacement.
see the importance in giving the line designers the tools they need to accurately model
We're
lines.
seeing extreme weather events throughout the country. And so, what do we look for the next 50, 100 years to design for our lines?
Hello, everyone, and welcome to a special edition of Power Perspectives, coming to you live from sunny San Diego at the epicenter of the utility industry this week, DTECH 2026. My name is Matt Chester, and I'm excited to be chatting about one of the buzz keywords that we're hearing all over the conference floor today and all this week, which is reliability. Specifically, we're seeing conversations about protecting an aging power grid in the face of major weather events, overground vegetation, and more. Is the solution building more resilient equipment? Is it overconductoring, undergrounding? The list goes on. But the goal is clear: taking action now to keep the lights on and speed restoration when things go wrong. And to walk us through what that means in practical, forward-looking ways, I'm joined today by Drew Pearson and Emily Witcher from Southwire. They're going to bring some real-life lessons based on decisions they've seen utilities make, what went right, what could be improved, and the kinds of systems that they see as most effective today for a more resilient grid tomorrow. So Emily, Drew, welcome to Power Perspectives.
Thank you for having us.
Yeah, thanks for having us, Matt.
Wonderful. So before we get into the meat and potatoes of the reliability and transmission discussions and debates, I'd love if you could introduce yourselves to our viewers. Can you give us a quick rundown who you are, what you do at Southwire, and how you got involved in this space to begin with?
Yeah, I'm Emily Witcher. I am the manager of our overhead transmission engineering team. And our team works with customers to provide technical expertise to them to provide that customer service. We do things from line design, ampacity calculations, anything that they need in using our products on the grid.
Yeah, I'm Drew Pearson. Thanks for having me on, Matt. I work under Emily at Southwire. She kind of went through what we do, but I'm a transmission engineer by title. My primary responsibility is to support our utility customers in the bare overhead product space. So my work involves applications, specifications, testing, R&D projects, and installation related stuff, even some software development. So it's kind of what I do at Southwire.
Wonderful. It sounds like you guys are really in the heart of what's going on, what's top of mind for utilities these days. So can you walk us through some of the biggest operational challenges you see in the world of overhead transmission, especially like I mentioned in the intro, extreme weather, vegetation management, wildfire risks? What are the main topics of focus that you have these days?
Well, it's really no surprise to anybody, but capacity seems to be the biggest topic that all the utilities are talking about. How do we increase that ampacity? How do we increase that load on the network? And a lot of utilities want to use what they currently have. Obviously, they don't want to spend money to fully rebuild lines, to build new lines. And so they're looking at their existing lines, seeing how far they can push those limits. And so with traditional lines that use ACSR or AAC and this hardened aluminum, you can really come to a point where you're running that line too hot. And so then you're causing that aluminum to anneal. That annealing of the aluminum makes the conductor lose its strength. And then you also worry about sag. The more load you're putting on that system, you're causing that conductor to sag more and more. And so if it wasn't designed for those parameters, you're potentially sagging into vegetation, into right-of-ways. And if you're not properly maintaining that, you could cause some outages and faults. With that, you mentioned weather as well. And, as everybody knows, we're seeing extreme weather events throughout the country. And so it provides a lot of questions for transmission and distribution line designers of what parameters do we design on? What do we look for for the next, 50, 100 years to design for our lines. So lots of unknowns for them.
It sounds like we kind of have a combined issue of the old, where it's, hey, this is the existing infrastructure and it's aging, combined with the new of, this load factor, the capacity factor that you mentioned, data centers, everything that's coming on. So it's kind of getting hit from both ends. And how do utilities kind of triage the priorities there?
Right. And a lot of times it's looking at, where are those data centers going? Where is the load needed? What's on the current line? And then trying to use as much as possible of what they have existing, whether that's using existing towers and then putting in new conductors, new advanced conductors that are lower in sag, but higher in ampacity, higher in those loads. We see a lot of utilities doing that these days.
Now, are there any specific myths, misconceptions that as you have these conversations out in the show floor these days, utilities coming up to you talking about these challenges? Is there anything that you would advise as, let's correct this one. Let's set the record straight.
Yeah, Emily talked about advanced conductors, kind of another buzz phrase, so to speak, in the industry that's thrown around a lot these days. And there's tons of misconceptions. But one I want to hit on is that all advanced conductors are created equal. They're not. And, Southwire's kind of put itself in a unique position with its C7 conductor. It falls under the advanced conductor category in we'll call it the CFC realm, which is carbon fiber composite core conductor realm. A lot of utilities that we work with think that those are interchangeable, but Southwire's design really is unique in that we have a stranded carbon fiber composite core conductor design. And stranded designs, they give you added flexibility, easier installation, reliability, there's that buzzword, and also strength redundancy that you want in a conductor core. So whether you're talking about steel core or carbon fiber composite core, stranded cores really make sense. And so Southwire's got a unique solution with its C7 conductor that really checks all the boxes for overhead conductor, for what you want in an overhead conductor.
And so the holdup, you'd say, from the utility side is the lack of knowledge that kind of solution is out there, or is it an issue of investment? What's kind of the holdup?
I mean, we get a lot of requests for conductors that maybe the customer thinks we provide, but they don't all fall into one bucket. So we have like I said, a unique solution with C7 that may not be exactly what they want, and it's not entirely interchangeable, but it could be a better direction to go when they're reconductoring, building a new line, anything like that. Second, I think the industry has had a hard time fitting ACSS into that advanced conductor category. I think it may have something to do with it being kind of an older conductor, and advanced conductors, people think they need to be some new design that's out there. But ACSS, even though it's 50 years old, still works great in reconductoring scenarios. It's still got the highest temperature rating in the industry, and still has great thermal sag. Now, when you compare thermal sag of ACSS to C7, C7's got near zero thermal sag. Yes, it does beat it out, but when you're looking for a cost-effective solution, ACSS can do that for you and can be great in reconductoring scenarios where you don't want to pay an arm and a leg for a carbon fiber composite conductor.
Great. And so that kind of answers the, what's out there for utilities in the physical replacement or upgrading realm. But what about on the software side or the operational side? What other kind of tools can they engage in that might provide some more relief or forward-looking, stability?
Yeah, so there's a lot out there software-wise. If you kind of start with the conductor, you're reconductoring, looking at what to put on this line. Southwire offers some softwares. One of our main ones is SAG 10. It's a sag and tension calculator essentially that helps utilities to put in those parameters. What are those weather conditions? What is that line going to see? And then they can look at what that ultimate sag is. So that kind of helps them in that reconductoring phase where they're probably limited by wanting to use the same size towers. And so you're limited how much sag you can have. We also offer a software SW rate that allows utilities to see how much ampacity. What is it going to do to the conductor when you put X amount of ampacity? What's that temperature be? So that software also can do a lot of batch calculations. So it's helping utilities with the recent FERC AA1 order that requires them to use the ambient adjusted ratings. So a lot of stuff on the design side. On the back side, we also offer a software digital grid solution that allows utilities to pull in all of the data that they're grabbing from the grid, from everything they've got on the grid. And it pulls that data and shows where those faults are happening, what equipment may be causing those faults. So then utilities can look at that information, see maybe where the problems are, and address those by which one is the most important, which one are we seeing the most faults. But it also allows them to plan that out over a few years. They're not just having to do it all at once. And I think there's a big preventative maintenance push as well. Let's not wait till it fully fails, but let's replace it. But nobody wants to replace it too early.
Right.
That wastes money. And so this
Especially when we're in
software,
the affordability kind of era of utilities.
right. Everybody wants to use what they have. We're limited in resources, limited in time. And so this can really help give a very targeted approach for the utility to know, how to go to the commission for rate increases and where they need to improve their lines.
Yeah. So with all these solutions you're talking about, is there any, recent implementations that, kind of case studies that work to show, what's the process and where do you come in terms of planning, implementing, follow-up? Are any, big field projects come to mind in that way?
Yeah, so I can talk about a project we
Yeah.
had in New Orleans
Okay.
that really kind of hits on that reliability aspect. So everybody knows about Hurricane Ida, came in 2021, and the utility down there, Entergy, really saw a lot of devastation. Well, the city itself and Entergy saw a lot of devastation, and that included a river crossing that they had going across the Mississippi River. So they had a structure come down on one side, conductor fell in the river, complete rebuild needed, right? So Southwire was involved with that in order to develop a conductor solution that would fit into that rebuild. And a few facts that I can share from it that'll kind of hopefully blow your mind. I don't know, but
I'm here for it.
the concrete pilings for the structures were 65 feet long. The structures themselves, they were tubular steel, but kind of looked like lattice structures. They had 4 legs, were 475 foot high. The river crossing itself was almost 1,500 foot long. I think it was right at 1,380 or something like that. And the new line was going to be designed for 175 mile an hour wind. Once complete, this was going to be a system hardened, or a system that was indeed hardened. So Southwire's part in that was providing a 954 kc mill type 23 arches C7, which used thermal aluminum zirconium alloy. So not quite as impressive as the other stats I gave you, but it really fit into the whole equation and was a heavy duty conductor that helped the system as a whole, accomplish the goal of system hardening. And with the C7, you're able to pull the conductor up to high tension, decrease your sag, not have to worry about clearance issues over the river. And we worked through some special installation needs that they had to and actually did some testing for them to give them confidence that there wouldn't be any issues with installing the conductor. And it's really a great project, and um, put our name out there because at the time we were still kind of working on getting the industry used to our conductor. So a project like that and a utility partner like Entergy really helped us to accomplish that goal.
Yeah, you mentioned the 175-mile-an-hour wind protection is obviously that's hurricane country. Was that a level, well, a hardening that you had to kind of convince them was necessary, or was it a in the aftermath they realized we want the top of the top? What was your role in
Right.
kind of getting them to that level?
We didn't play a part in that. The line had been modeled for 150-mile-an-hour wind, and you saw how good that went.
Sure.
You had a structure on the ground, so
Yeah.
obviously they don't want that to happen again. So I think that kind of lended to their increase in assumed wind load. Next hurricane that comes around, that line should still be standing.
That's obviously a project that sounds like went according to plan, was great to see. Are there, in other projects, kind of pitfalls that you tend to see? You mentioned, needing to kind of educate the utilities that not all these conductors are built the same. They're not, uniform. So there's a reason to look at all those. Are there other pitfalls that come up when you're, in the early stages of these projects?
One aspect of line design that we really try to drive home with line design engineers is accuracy of their modeling.
Mm.
Um, the industry has had historical data that's been used for modeling overhead lines when it comes to stress strain charts, and those play a crucial role in predicting sag. Um, but with the development of new conductors and the cost of testing those new conductors, we've seen manufacturers go to a more theoretical approach for characterizing stress strain and creep behavior of conductors. Southwire has a test program which we call our Southwire Certified Test Program. We've done countless stress strain and creep tests over the past decade and then some, um, because we see the importance in giving the line designers the tools they need to accurately model lines, because you've got public safety that's at risk if you don't. So especially with the development of advanced conductors, you don't have historical data you can lean on. So you want to repeat test, perform new testing on these conductors. Um, and we would really encourage engineers to take a trust but verify approach. When you do line designs, you tend to just throw in a file and then not think anything else of it. But we would encourage those engineers to ask for test reports from manufacturers to be able to see the data behind the coefficients they use. And that's what Southwire's test program was kind of built on, was being able to provide that data and give engineers confidence in their modeling approach.
Right. Yeah. You can never be too safe, and that's important. I mentioned reliability as one of the buzzwords of DTECH this year. I would be remiss not to mention the other one, which is AI. Everything out there is AI. So I'm curious how you see artificial intelligence and automation tools playing a role in this overhead space that we're talking about today.
Yeah, I mean, you're right. AI is popping up everywhere. It's getting used for all sorts of things. Southwire, as a manufacturer, we use AI in our manufacturing facilities. Recently, we've implemented it in to not only help optimize our manufacturing, but to also help lessen quality issues. And by lessening those quality issues, you really do lead into a more reliable system because you're making sure the product that goes out there is a quality product and you're not having issues on the line. On top of that, Southwire has been using AI through creating an AI chatbot to help utilities be able to ask questions, simplistic questions to get answers quickly. That way, we can kind of spend our time on some of those more hard hitting, really pressing questions to help them with. And I mean, we use AI daily in our work. From what I've seen, I think AI is also starting to be used in some grid monitoring from other companies. I feel like that's becoming a big thing, kind of monitoring what's happening currently on the grid. And then, like you said, using that data, getting it accurate so then we can use what we existingly have. With all of this, though, AI is a great tool, but it's not a replacement. It's not a replacement for engineering knowledge, for the history that engineers have at utilities, for that human judgment that really needs to come into play with AI. But I do think AI can come alongside engineers and really help us do our jobs better and faster as you see, we have low resources and need things to help us do things faster.
Yeah, I think AI is another area where we can the trust but verify. Trust what it says,
Trust
but
it,
hey,
you're better.
don't trust it completely. So, we're having this conversation a couple of days into the conference. So I'm just curious, reliability, AI. Are there any major themes that you would highlight that are important to you, or maybe were surprising that you didn't expect to have such a high billing as we're all gathered here?
Yeah, I know we talk a lot about, more capacity, more load on the system. And realistically, that load is coming from data centers for the most part. So we're seeing a lot of that. But with that data center coming into play, it's interesting. We're seeing a lot of players in the market. If you go look at a lot of the booths, it's not just your traditional manufacturers anymore that are selling products into the utility. It's a lot of the tech space, the startups coming into the industry and saying, hey, we've got some technological advances that could maybe help. And so it's been interesting to kind of see how the two have kind of merged together in the industry. And I think it's pushing the utility industry a little bit. We tend to be very slow in our adoption of things for good reason. We want to make sure there's a safety aspect there. But it's been interesting to see the two come alongside each other. And honestly, that's probably been the most surprising is I sat in on a data shop workshop with one of the hyperscalers. And they really do want to partner with utilities. They really do want to partner with manufacturers and get it done as quickly and in the best way possible, not just come in and kind of bulldoze the whole industry, but actually have a real partnership there,
Yeah.
which I think is encouraging.
Absolutely. No, I agree. And I think that's a great note for us to wrap this up on. So I thank you guys for joining us. And before we let you go, where can our audience go to read more and get in touch with you all if they've had their interest piqued?
Southwire.com is always a great resource. We have lots of technical white papers on there and calculators to be able to do some of this stuff. We also have a Southwire cable tech support website that has all of our data sheets and additionally those white papers. And then on top of that, people are always welcome to email us. We have a group email that is OHT, overhead transmission, at southwire.com. And we have people behind that email to answer the utilities' most pressing questions and how to really get them the answers they need.
Wonderful. Well, I'll make sure we have links to those in the notes of this episode. But thank you guys for joining us for this live recorded episode of Power Perspectives from DistribuTech 2026. I appreciate your time today.
Thank
Thank
you.
you.
Thanks for having us.